Hey, welcome everybody. This is the start of our geometry section, and we are gonna go through this geometry section and talk about proofs while talking about the concepts of geometry. So this is your first lesson on that, and it's if-then statements. Okay, so it's just the first little example of an if-then statement. If I live in Los Angeles, then I live in California. True, right? If you live in Los Angeles, then you live in California. In an if-then statement, there is always a hypothesis and a conclusion. Okay. So what is my hypothesis? It's always going to be the if statement. If I live in Los Angeles, so you know that, right? Then what do you know? Then I live in California is what I know, right? Based on this sentence. Okay. So if something happens, then this happens, right? If I live in Los Angeles is what I'm given. Okay, here. I live in Los Angeles. I give it as true. Then what I know, then I know that I live in California. Okay? P is going to be my hypothesis and Q is going to be my conclusion. And there are four different types of statements that can come out of this. Okay, so you guys see this arrow here. Yeah, all the way on the bottom. That arrow is the arrow for an if-then statement. So if P, then that leads me to say, then Q. All right? So just knowing that the the first statement, if I live in Los Angeles, then I live in California, is called my conditional statement. Okay? So in terms of P and Q, if P, then Q, right? The other term or the other statement would be my converse statement. And that's just flipping my conclusion and my hypothesis. Okay, so if Q, then P. My other statement is my inverse statement, where it negates both my hypothesis and my conclusion. So if not P, then not Q. Okay, and my contrapositive is saying it negates it and switches it. If not Q, then not P. Okay. And if you guys can see the red and pink stars, they are logically equivalent, meaning that if the statements are that the statements are both true or both false. Okay, so they will be logically equivalent. If one is true, then the other one is true. If one is false, then the other one is false. Okay, so they'll have the same value of true or false. Okay. So now that we got that, a biconditional statement, okay, is if both statements are true, the conditional, contrapositive, or the inverse and the converse, right? Those logically equivalent statements are both true, then we can connect them by putting if and only if. Okay, we'll do an example in a little bit. Okay, and if the statement is false, then you can provide a counterexample. All right, and we'll do counterexamples right now. So let's practice all these statements with our first if then statement here. So this is my conditional, right? If I live in Los Angeles, then I live in California. True or false? True. Okay. So it's true. So automatically, what do I know? Yeah, that Los Angeles is in California, but in terms of my statements, my contrapositive is always going to be true. Okay. So my next statement, I'm gonna put my let's converse. Okay. My converse states if Q then P. So I'm just switching my hypothesis and my conclusion. So it's gonna be if I live in California, then I live in Los Angeles. Correct? That's my contrapositive, or that's my converse, right? I flip the if and then statement. Is this true or false? It's true. If I live in California, then I live in Los Angeles. True or false? False, right? Everybody can conclude that this is false. Why?
Because you live somewhere else in California, not necessarily.
That is a counterexample. I can live in, I don't know, San Diego, right? I can live in San Francisco, right? I could live in Bakersfield. You guys know where Bakersfield is?
Yeah.
Barbara.
Yeah, so there's a bunch of counterexamples that we could come up with, right? A counterexample, or the reason why this is false, is because my if statement here, my hypothesis will always be true, but it leads me to a different conclusion, right? Can a counterexample be Honolulu? If you guys don't know, that's a city in Hawaii. Can it be that?
No.
No. The reason why is because it's not in California, right? Yeah, does that make sense? So a counter example is always going to be a place or an example where my hypothesis is true, but then it leads me to a different conclusion. Okay? Like San Diego, San Francisco, Bakersfield, I heard Santa Clarita, I heard Napa, Santa Barbara. Yeah, all of these are great examples. Okay? So if that's false, if my converse is false, automatically I know that this is going to be false as well. My inverse. My inverse negates both my hypothesis and my conclusion, right? So I'm going to put a not. So if I do not live in LA, then I do not live in, I'm going to try and put it all in one line, in California. Okay, without even reading it, without even kind of processing it, I know it's false because that one is false. Okay, but now let's comprehend it. If I do not live in Los Angeles, then I do not live in California. Counterexample would be Redondo Beach, right? Any of the ones that we already came up with. San Diego, San Francisco, Bakersfield, yeah. Napa, Santa Barbara. All of these cities are not LA. Yeah. But they are in California. That make sense? Yeah. So my hypothesis is still true, right? I still don't live in LA, right? I'm not in LA if I live in one of those cities, but I am in California. Okay. My last one, contrapositive, before I even set it up, I know that this is true. The reason why is because I know that my conditional is true. Okay, they will always hold the same logical value, true or false. Okay, so let's build it. They need you flip it and you negate it. Okay, so if I do not live in California, then I do not live in Los Angeles. True, right? Yeah. Okay. So again, if they are both true, my contrapositive is true, along with my conditional is true, right? If they're both true statements, I can make one statement called a biconditional. Okay. A biconditional, if I use P and Q, then it's going to be P and my arrow is going to go both ways. Q. Okay. So I don't need my if. I live in LA if and only if I live in California. That's my conditional. That's my biconditional. Okay. The word if and only if is the key part. Okay. That's what makes a biconditional. All right. You guys understand that? Yeah. That's my quick lesson for today, class. Okay. And this is the start of our proving things. And the big takeaway from this lesson is when we start our two column proof, yeah, we must have our if statement already stated somewhere. And I'll get into that when we hit proofs harder. Okay. Thank you so much, and I'll see you on the next one.